Hello, so this is a revision video for IB Chemistry S2.2.1, covalent bonds and Lewis formulas. In a covalent bond, a pair of electrons is shared between two atoms. The positively charged nuclei of both atoms get attracted to the shared pair of negatively charged electrons, and this pulls them in closer together. So actually, a covalent bond results from the electrostatic attraction between the shared electrons and the positively charged nuclei of both atoms. The stronger the force of attraction, the stronger the covalent bond. The octet rule describes how atoms tend to gain, lose, or share electrons to achieve 8 electrons in their outer shell. There are lots of exceptions to this rule, especially for smaller and larger atoms. However, it can be a quick and efficient way of predicting how many covalent bonds an atom is likely to form. Lewis structures are diagrams used to show how electrons are involved in the bonding between atoms. They show all valence, so outer, electrons of bonded atoms, including bonding pairs, so electrons between atoms, and lone pairs, so outer electrons on a single atom that aren't involved in bonding. The electrons are represented as dots. To draw a Lewis structure, we first count the total valence electrons around each atom. We then connect the atoms together with single bonds. Remember, one shared pair equals 2 electrons. We then distribute the remaining electrons available to complete the octets for each atom, so make sure each atom has 8 electrons on its outer shell. And then we can use double or triple bonds if needed to satisfy the octet rule for each atom. Some atoms can be stable with less than 8 electrons. For example, beryllium in beryllium chloride, BeCl2, forms 2 covalent bonds, given a total of 4 outer electrons. The boron in Bf3 forms 3 bonds, given a total of 6 outer electrons. These are exceptions to the octet rule that you should recognize and be comfortable with. Sometimes bonded atoms can have more than 8 electrons in their outer shell, such as SF6, and this is referred to as an expanded octet. This is covered in much more detail for AHL students in S2.2.13, Expanded Octet and VSEPR.